All right, welcome back, computer science students. We just finished our discussion on the organization class, and in particular highlighting these public static final variables, the fact that they're used to define types across all organizations. And so now let's actually take a look at, we're really going to focus on the bug that we created, or that is present, the misuse of static. And to do that, we're going to look at our code and run through, verify that everything looks okay, and talk about why it might not look okay. Just as a quick little, make sure you understand static here. So, we made a string indent that's going to help us. You'll see it show up a few times down here, making sure that we indent all of our organizations nicely. We create a student, the CS president, called Taylor Smith, give them an ID, and then create the CS club organization. And so we're going to create it with the name CS club, president of the student that we had. And so I just wanted to highlight real quick as we move on here, you can, when you create your own classes, refer to or have objects from another class inside your class, right? So my organization class has students. In fact, it has an array list of students. So this is a has-a. Organizations have students, so the relationship between organizations and students is called a has-a relationship. If you look this up, this is a common term that basically means one class has instances of another class in it. So organizations have students. It's a has-a relationship. So organizations, when I create it, need to have a student, and then we're going to define this as an academic type organization. All right, so if we look down here, everything looks okay. We have a CS club, its type is 100, which is fine, right? Let's see if we can verify that. Academic type we have defined as 100, so that makes sense. From a programmer side, this is working as intended. We set organization to 100, and it has members. And in particular right now it has one member, Taylor Smith. The way this class is set up, the president will always be the first member in this list. So you'll see a list as we go through with more members. The president is always listed first. All right, so the next thing we do is we create a student for it to be the hockey president, Quinn Jones. And he's going to create the club hockey team where he is the president and is a club sports type. So that's type 200. So everything's still looking okay, right? We created club hockey, its type is 200, and its members, it has one member. So that makes sense. So it still looks okay, but here's where we have a problem. I'm going to highlight why we have the problem in a second. If I now try to print my CS club, it doesn't quite look right. Now my CS club, when I print it out, has a type of 200 rather than a type of 100. So why would let's see, the method that we print out here, indent plus CS club, if we look at our print statement where we're printing our CS club, that means we need to look at our toString method. When we print the type out, we're just printing this variable type, and the variable type isn't working correctly. So that tells me I need to go back and look at type. So if I go back and look at type, I made it static. So why did I make it static? Well, we didn't really talk about it. We kind of skimmed over. Private static int type. Well, this is a common mistake. So students look and they say, all right, well, types are static. You know, the type definitions are static, therefore the type variable should be static. But remember, static means it belongs to the class, not to an individual object. So that means when I set type to 200, when I create my hockey club, by setting it equal to club sports type, it's going to update it for all of my classes, or for all the objects in my class. And so when I try to print my CS club type, I get 200. So it's now a club sports type because the last organization I created is club sports. If I kept creating another organization, then the types of all my organizations are going to be the same. So the distinction is type definitions are the same across all organizations, but each organization in and of itself has its own defined type. So you would not want static for private and for the type. You want each organization should have its own type, but all organizations should follow the same definitions for types. So static for the definitions, not static for what each organization's type should be. So this is the important distinction about static, and this is how you use static with fields. So this is where a lot of confusion can happen with students. If we fix this, then let's look at our list. Now the printouts aren't going to make sense, but we've cleaned it up. So CS Club is type 100, Hockey Club is type 200, and now CS Club has maintained itself as type 100 because each object stores its own type. Before, if we tried to fix it, so let's make sure we go back and look at static. If we try to fix our CS Club, so it wasn't looking okay, the type was changed to 200. Then when we fixed it by setting the CS Club's type back to academic, well, since type is static, it changed Club Hockey's type to academic. And so you see with static variables, any change that you make for one object applies to all objects in the class. So static variables apply to the whole class. When we get rid of static, we'll see that each object can maintain its own type. So CS Club is type 100, stays type 100, Hockey Club stays type 200. It could get worse because the more clubs you have, the more times when you change a thing, it changes all the things. Right? So it changes all the clubs to Greek type if I make a Greek club. So it kind of could get worse. And so the tester code was fine, right? If you look at this, I kind of helped point out that we should be looking back in the organization class and fixing the type. But when it's debugging, this is one of the really hard things to catch because, you're running along and you start looking at your code and you say, well, my organization's types are not updating correctly. I must be doing something wrong with set type or with how I create objects, and it can be really hard to debug. But if you ever see a value changing for all instances, for all objects that you create at a time, then the key thing, the thing that you should know to debug, and the thing that you should say, oh, I know what this is a static problem. Because if it changes for all objects, that means it's a class-based variable, which means that it's a variable that applies to everything in the class, which means that it's defined with the static keyword. So this is a common problem. The code here is fine, the set type method's fine, the constructors are fine. The only problem was changing type to static. So it's a very powerful keyword that can cause a lot of problems. Static is only for variables that belong to a class. Static, use a static for a variable when you only need exactly one variable, regardless of how many objects you need. If each object needs its own variable, don't use static. Fixing, oh yeah, that's the other highlight here, is if you try to fix a problem in Eclipse, and Eclipse suggests that, oh, why don't you just make this static? It's probably wrong. You probably should not do that. If you're not sure about a problem and you see a suggestion to make something static, don't do it. And so really the base key is don't ever use static unless you know that you should, unless you know that it is for a specific method. So let's jump in next time. We're going to do one more example to talk about static methods. We spent a lot of time talking about static fields because it's the most common place for it to show up, but we're also going to talk about static methods.